Hello, physics, DC circuits, potential divider. And the question is, a power supply has a fixed output voltage of 12 volt, this 12 volt, but VT, that's the voltage at the terminal, is 3 volt is needed. Using the voltage divider circuit as below, this one, this is not a resistor. Below, what would be the resistance R2 if R1 is 10 ohm? So R1 is equal to 10 ohm. And B, what will be the terminal velocity voltage Vt if a load resistor to the 3 volt terminal is attached, assuming the load resistance is 7 amp, 7 ohm. So this is equal to 7.0 ohm. So load resistor definitely in parallel. So first of all, A. If you find A, the solution, we have to find R2 and VR2, which is VT, which is a VR2. This is given, which is the 3 volt. That means VR1 is equal to 9 volt because VR1 plus VR2 total is 12 volts, this one. So we know R1 is equal to 10 ohm. So from here we can find out the current. The same current is flowing. So series circuit. In R1 and R2, but different voltages. So same current. So V is equal to IR. That means I is equal to V over R, or in this case V1 over R1, which is equal to V is 3 volt, R is equal to 10 ohm. So this is equal to 9 ohm. 9 ohm, this one, 9 ohm, which is equal to 0.9 amp current. So V is equal to IR for R2 resistor. So now we can find out the R2. R2 is equal to V over I. V2 over I. I is the same. V2 is 3 volt. I is equal to 0.9 amp. So R2 is equal to 3.3 ohms. So that means if resistor is if first resistor is 10 ohm, second resistor is 3.3 ohm, then this voltage is 3 volt. Now B part. We have this resistor. This is R1. This is R2. And in parallel is RL, load resistor. So first this one, reciprocal of this one. So V equivalent 1 is equal to 1 over R2 plus 1 over RL raised power minus 1, or it is equal to R2 RL, R2 plus RL. So if you use this one, R2 is R2 is 3.3 ohm, RL is given 7.0 ohm. So 3.3 multiplied by 7.0 ohms. So 3.3 plus 7.0. So this is equal to 2.26. 2.26 ohm. So R equivalent 1. So that means this circuit is now R1 and R equivalent 1. Now the equivalent resistance of this one, series. So this is parallel. Now it's series. So R1 plus R equivalent 1 is equal to R equivalent 2. So series. So R equivalent 2 is equal to R1, which is equal to 10 ohm, 10.0 ohm plus 2.26. So this gave us the answer 12.26. So this is equal to like this one, positive, negative. So we can find out the current flowing through this one. So V is equal to IR. So in the series circuit, same current, I is equal to V over R equivalent 2. So V is 12 volt. So 12.0 volt over 12.26 ohm. So nearly 1, it is equal to 0.97, 0.978 ampere. This is the current. So this current is flowing this one. So now come to this one circuit. So this positive negative, this is R1, this is R2, this is load RL. Now if we find out the voltage across this one, so current is flowing the same. So the voltage is equal to V T, so through is I R2, which is equal to 0.978 ampere multiplied by ohm, which is equal to 3.3 ohms. 3.3 ohms. So this will give us the value 2.2 volt VT. So that means by adding a parallel resistor, we can reduce the voltage. So from 12 volt to 3.3, 3 volt, and 3 volt to we can reduce is 2.2 volt. So by R2, using R2, which is equal to 3.3 ohm, and R2 plus RL in parallel. So we can reduce it to 2.2. 2.2. So this is the conclusion of potential divider. So this is the question. This is a part 1. In part 1, we have to find R2. And in part 2, R2 and RL is in parallel. And we have to find new voltage through passing through R2. This is 12 volt. So this is 2.2.